This is Chemistry Made Simple YouTube channel. I take this opportunity to welcome you to another great learning segment. Our topic of concern today is the nomenclature of carbonyl compounds. First and foremost, what are carbonyl compounds? Carbonyl compounds are compounds that bear the carbonyl group as the functional group. Displayed there is the structure of a carbonyl group. Depending on groups attached to the carbonyl group, we can have two different classes of carbonyl compounds, and these are aldehydes and ketones. For that case, therefore, our presentation today will be subdivided into two parts. In the first part, we learn how to name aldehydes, and in the second part, we learn how to name ketones. Welcome to the first part, nomenclature of aldehydes. First and foremost, let us first understand the general structure of an aldehyde. Displayed there is the general structure of an aldehyde. Notice that R can stand for an alkyl group or an aryl group or simply a hydrogen atom. When R is a hydrogen atom, then the aldehyde obtained is as displayed there and is generally known as formaldehyde. Also, when R is a methyl group, then the aldehyde obtained is as displayed there and is known as acetaldehyde. The words acetaldehyde and formaldehydes are trivial names, and we do not concern ourselves with the basis of their origins. However, we have to learn how to name aldehydes in a systematic, recognized, scientific way. How do we name aldehydes? According to IUPAC, the name of the aldehyde is generated by replacing the suffix E in the name of the corresponding alkane with the suffix Al. To illustrate this guideline, displayed there is a single carbon aldehyde which corresponds to the single carbon alkane methane, and by following the above guideline, the name of that compound there is methanal. Also displayed there is a 4-carbon chain aldehyde which corresponds to a 4-carbon chain alkane butane. Now, basing on the above guideline, the name of that aldehyde is butanal. However, when the carbonyl group is attached to a cycloalkyl group, then the name of the generated aldehyde is named by first and foremost writing down the name of the cyclic alkane followed by a separate word, carbaldehyde. To illustrate this, the displayed aldehyde there is a combination of cyclic butane and carbaldehyde, and therefore the name becomes cyclobutane carbaldehyde. In the event of naming alkyl substituted aldehydes, then the same guidelines used in the naming alkyl substituted alkanes must be followed. A quick review of these guidelines is as follows. First and foremost, we have to determine the parent chain, and as we have said, the parent chain must be the longest carbon chain, and in this case, it bears also the carbonyl group. The second guideline is that we assign numbers to carbon atoms of the parent chain by starting from the carbonyl carbon. The third guideline is a repetition of guidelines used in naming alkanes, which helps us to name repeated alkyl substituents. Two similar alkyl substituents are represented by using the prefix di. Three similar alkyl substituents are represented by using the prefix tri. Four similar alkyl substituents are represented using the prefix tetra, and so on, as derived from Latin. And our final guideline is that if there are different alkyl substituents on the parent chain of the aldehyde, then when writing the name of this aldehyde, the names of these alkyl groups should be written by respecting their alphabetical ranking. At this point, let us try to practice these guidelines by naming our displayed compound there in illustration number 1. After observing the compound, our first guideline is that we determine the parent chain. As I have said severally, the parent chain must be the longest carbon-to-carbon chain in the compound, but in this case, it must also bear carbonyl group. Without wasting time, the yellow highlighted carbon-carbon chain is our parent chain, which, by the way, helps us to generate the parent name heptanal. The second guideline is that we have to assign numbers to carbon atoms on the parent chain by starting from the carbonyl carbon. This has been done as displayed there. After numbering, realize that we do have two different alkyl substituents, and these are two ethyl groups and two methyl groups. By following the alphabetical arrangement of these alkyl groups, we can therefore write down the name of the displayed compound as 3,3 hyphen diethyl hyphen 5,5 hyphen dimethyl heptanal. Our second illustration displayed there also is for nomenclature, and after observing our illustration, realize that we do have a cyclic chain with a carbonyl group attached to it, and without wasting time, the parent chain is that cyclic chain with the carbonyl group, which generates the parent name cyclohexane carbaldehyde. After determining our parent chain, we proceed to our second guideline, and at this point we assign numbers to carbon atoms of this parent chain, but we should do it either clockwise or anti-clockwise in a manner that will give the carbon atoms attached to the substituents the lowest numbers. Without wasting time, this will be done following the clockwise direction, since the clockwise direction places the substituents on carbon atoms number 2 and number 4 respectively. This has also been done as displayed there. At this point, realize that you have two different alkyl substituents. That is, on carbon number 4 there is a methyl group, and on carbon number 2 there is a secondary propyl group. We therefore write down the name of the displayed compound following the alphabetical arrangement as 4-methyl 2- secondary propyl cyclohexane carbaldehyde. At this point, we have come to the end of nomenclature of aldehydes. Let us go to the second part of our presentation, which is nomenclature of ketones. First and foremost, what are ketones? Ketones are represented by the general formula displayed there, and in this case, R stands for strictly alkyl groups, or for that case, aryl groups. If R is a methyl group, then we have the ketone displayed there, whose common name is acetone. However, we do not concern ourselves with the name acetone, but rather with the correct scientifically accepted way of naming ketones. How are ketones named? Generally, ketones will be named by basing on the format displayed below. Now, on that displayed format, the word alkane is generated from the name of the corresponding alkane, and the locant of the carbonyl group is obtained by numbering the carbon chain of the ketone, starting from the side of the ketone closest to the carbonyl group. Let us practice that general guideline by naming the displayed compound there. That displayed compound has 3 carbon atoms and therefore corresponds to the alkane propane. From the word propane, we generate the word propane. After numbering the carbon atoms of the compound displayed, we establish that the carbonyl group is on position 2, and therefore the name of the compound becomes propane-2-one, which is simply pronounced as propan-2-on. Further practice on the above format, let us also name the displayed compound there. Now realize that the compound has 5 carbon atoms and therefore corresponds to the alkane pentane. Now, after numbering the carbon atoms, we establish that the carbonyl group is on position 2, and therefore the name of that compound is going to be pentan-2 -one, which is simply pronounced as pentan 2-on. In case there are alkyl substituents along the carbon chain of the ketone, then the naming is done as follows. Step number 1, determine the parent chain. And in this case, the parent chain must be the longest carbon chain in the ketone that bears the carbonyl group. Step number 2, number carbon atoms of the parent chain, starting from the end of the parent chain that is closest to the carbonyl group. Step number 3, presence of similar alkyl substituents is indicated by using prefixes di for 2 similar alkyl substituents, tri for 3 similar alkyl substituents, tetra for 4 similar alkyl substituents, penta for 5 similar alkyl substituents, and so on, as derived from Latin. Different alkyl substituents must be written in alphabetical order. At this point, we try to practice the above guidelines by naming the displayed compound. After observing the displayed compound, we identify that the parent chain is the yellow highlighted carbon chain. After determining the parent chain, we go ahead and number carbon atoms of the parent chain by starting from the side of the chain that is closest to the carbonyl carbon, and this has been done as displayed there. Now realize that on position 2 of the carbon chain, we have our carbonyl carbon. On position 4 of the carbon chain, we have 2 alkyl substituents, and both of them are methyl groups. We can therefore write down the name of the displayed compound as 4,4 hyphen dimethyl hexane hyphen 2 hyphen one, that is simply pronounced as 4,4 dimethyl hexane 2-on. At this point, I would like to welcome you to our live chemistry classroom, where we shall have the opportunity to physically practice these rules by naming the displayed compounds. Welcome to the classroom, and before us, we're supposed to name the compounds. And whenever you are naming, please always remember that you name organic compounds by basing on IUPAC guidelines. So without wasting time, let us first examine our compound to see the functional groups that are present. The functional group that is present is this one, which simply represents the carbonyl compound and specifically aldehydes. That being said, let us proceed to the first guideline and determine the parent chain. The parent chain is always the longest carbon chain in the compound that bears the functional group. As I've always advised you, always transverse the compound and obtain all the possible carbon connections, and the one with the highest number is the one that qualifies to become your parent chain. So without wasting time, this that I have enclosed in red ink, faint red ink, is our parent chain. After that, we proceed and assign numbers to carbon atoms on the parent chain, but we have to be careful that we start from the carbonyl carbon, and this is going to be like this. So this is carbon atom number 1, number 2, number 3, number 4, number 5, and number 6. After numbering, we can be able to conclude that the parent name or parent chain is, and then also the positions 3 and 4 are of consideration. Why? Because on these two positions we do have substituents, and the substituents are, by the way, this, which we have called a methyl group or simply methyl, and this one, which we called secondary propyl. So these two substituents are different and they must be written in alphabetical order. So without wasting time, The name of this compound is therefore 4-methyl 3 secondary propyl, and then our parent name, which we have obtained as hexanal. As simple as that. For matters of emphasis, I enclose it in blue ink like this. Following from part A above, we still have part B here, which we are also supposed to name by basing on IUPAC guidelines. The first step, as I've said, first examine your compound. Now, upon examining our compound, this is our functional group, this one, which is a carbonyl compound, and specifically, this carbonyl compound directs us that this is a ketone. Now, guideline number 1 from IUPAC is that determine the parent chain of the compound. The parent chain is always the longest unbranched carbon-carbon chain in the compound that bears the functional group. Without wasting time, this that I have enclosed in faint red ink is our parent chain. After identifying our parent chain, which by the way has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 carbon atoms. Now, after identifying the parent chain, we assign numbers to carbon atoms on the parent chain, starting from the end or from the start or from the left or the right of the parent chain, such that this carbonyl carbon has the lowest number. But for this specific compound, either way, starting from this side, puts your carbonyl carbon at number 5, and also from that side, it puts your carbonyl carbon at number 5. So either way, you will attain the same result. So this is position 1, position 2, position 3, position 4, position 5, position 6, position 7, position 8, and position 9. Now the positions that are of consideration, we do have position number 3, which has an ethyl group, and also position number 7, which has another ethyl group. So the ethyl groups I'm talking about are this one, and so is this one. These are the 2 ethyl groups. So at this point, we have to write the name of our compound simply as position 3 and position 7. We have 2 similar groups, so for that case, diethyl. At this point, we have already named the 2 substituents. So we have to now write down the parent name. The parent name is derived from a 9-carbon chain alkane, and therefore from that we get the prefix non, followed by a hyphen, and specifically on position 5 we have our functional group, and this becomes the name of the compound. I'm encircling it in blue ink just for matters of emphasis. Do you have any challenge as regards the learning or even teaching of organic chemistry? Please, you can contact me by using the email address in the description of this video, and I will honestly get back to you. Until next time, I remain yours truly, your chemistry teacher. Goodbye.